Okay, let's continue. So we'll study points as vectors. So vectors are directed line segments. A vector is just a directed line segment. So especially note that a vector is determined by its length and direction. To specify a vector, you just need to specify its length and direction. For example, all these vectors, so all these vectors are equal. So all these vectors have the same length and the same direction, hence they are equal. A vector is determined by its length and direction. Okay, so a vector is just a directed line segment and it is determined by its length and direction. Now note that we can view points as vectors. We can view points as vectors with initial point at the origin. So for example, this point, so this point can be viewed as a vector 3 comma 2. This point 3 comma 2 in the coordinate plane, this can be viewed as a vector with initial point at the origin. So we can, whenever we think of a point in the coordinate plane, we can think of the vector from origin to that point, and we can treat that point as simply this vector. So this vector is 3 comma 2 and this vector is 1 comma minus 2 and so on. So points can be viewed as vectors in this way. So another example would be, so this point would be, this vector would be minus 1 comma 1 and so on. So points can be viewed as vectors. In three-dimensional space, we can do the same thing. For example, so 1 comma 2 comma 2, we'll think about this parallelogram. So the box, we can think of this as a vector 1 comma 2 comma 2, right? So points can be treated as vectors from the origin, beginning at the origin. Points are just vectors beginning at the origin, so we can treat points like that. We will study vectors in 3D space later. Okay, so points can be considered as vectors beginning at the origin, and we look at an example. So consider vectors PQ in the plane. Given two vectors, you can always translate them so that they begin at the origin. A vector is just determined by its length and direction. So okay, so these are two considered, or I'll say points. we already said um, points can be considered as vectors, but converse is not true. Vectors cannot necessarily be considered as points because all these vectors are same. So you can't really use just a vector to specify a point, but a point can be thought of as a vector. Okay, so consider points PQ in the plane. We saw that P plus Q is given by completing the parallelogram. So to find P plus Q, we just complete the parallelogram. So this is P, this is Q, and we saw that the point P plus Q is given by completing the parallelogram. So this is P plus Q, this point is P plus Q. Hence, we have this picture in fact. P, Q, this is P plus Q, and we have this picture. If we translate this vector Q to be the other side of the parallelogram, we get this nice picture. P plus Q is, so P, Q and P plus Q form this kind of a triangle. Hence, we get one more interpretation of addition of points. If these points PQ are viewed as displacements, then P plus Q is the natural sum or resultant of the two displacements. So from this picture, from this triangle, we see that P plus Q, if we treat the vectors P and Q as displacements, then P plus Q is the natural sum or the natural resultant of the displacements P and Q. So likewise for scalar multiplication. So if you take a point, for example, you can think about scalar multiplication by 2. You can think about this point P, and twice this point is just this. So this is 2P. So scalar multiplication of points and scalar multiplication of vectors, that is natural. And for addition of points, addition of vectors, addition of points, we saw that addition of points just means you are completing the parallelogram and considering the constructed vertex. And in terms of vectors, what it means is you have this triangle. So to add P and Q, to add vectors P and Q, you just take the natural sum. You translate the vector Q such that its beginning point is at the end point of P, and then, okay, it's hard, it's unnecessary to describe in words, but by forming this natural triangle, you can find the resultant, the sum of two vectors. So addition of points, addition of vectors, and addition of vectors. You can think of this as just addition of points only, but this is one more way to interpret the addition of points P and Q. That's all it is. And even this can be considered just like the scalar multiplication of points. This is just one more way to interpret scalar multiplication of points. Okay, so we got one more interpretation of the sum of 2 points in the plane. So To specify an example, consider vectors p equals 1 2 and q equals 3 1. So note that the sum p plus q is we just complete the parallelogram. So this vector is 1 comma 2, this vector is 1 comma 2, and this vector is 3 comma 1, and you can complete the parallelogram to get the sum of these two vectors. So this vector is also 3 comma 1, and addition of 1 comma 2, the 1 comma 2 vector and the 3 comma 1 vector gives the vector 4 comma 3. So this is the geometric interpretation of the addition of these 2 points, 1 comma 2 and 3 comma 1. 4 1 comma 2 plus 3 comma 1 is 4 comma 3. Okay, so this is just one more way to interpret the addition of 2 points as using vector ideas. So treating the other point as a vector, you get this natural triangle, and so this is one more interpretation. Okay, so that's all for this part. See you in the next part.